As we've talked about demand, one of the things we talked about was the law of demand. And with the law of demand, it talks about that inverse relationship between the price of the good and the quantity demanded. So it says as price goes up, quantity demand goes down. Price goes down, quantity demand goes up. Right? But the question is, part of the question is, how much does the quantity demanded change in response to a price change? So let's look at an example here. So let's say here that we have the case where we have two distinct price change, or one price change with two demands. So we have demand A and demand B. So in both cases, we're going from P0 to P1. And let's just assume that in this case, that P0 price has the same quantity demanded for both demand curves. Now, in demand A, when we go down to P1, we see a relatively small change in quantity demanded. So the number of units does not go up by that much. With B, however, demand B, we see that when that price goes from P0 to P1, we see a much larger increase in the quantity demanded. So basically, not every demand curve is created equal. And because of the implications in the business world and just real life application, it becomes important to find a way to illustrate and measure these differences between demand. Because, in this case, for example, if you're a business owner, you're thinking about decreasing your price or increasing it, you want to have an idea of the implications of that. So this brings up what we call elasticity. Elasticity, when we're looking at price elasticity of demand, we'll talk about the others another point, it's the responsiveness of the quantity demanded to a change in the price. So basically it says price change. What was the effect on quantity demanded? Now, this is what we call a units-free measure. And basically it's, for example, let's say that price went from 1 to 2 and quantity demanded went from 99 to 100. Okay. So you might look at that and say, all right, well, price went up by 1, went from 1 to 2, quantity demanded went up by 1, 99 to 100. So they had roughly the same effect. When in reality, they didn't, because price doubled while quantity demanded only went up by a little bit, a little more than 1%. So what we're going to look at is we're going to take out those units and look at it in more of a better scale. The all else the same, that's kind of the standard we use in economics. It says no other factors are influencing it. So the formal definition of price elasticity of demand is here. The price elasticity of demand is a units-free measure of the responsiveness of the quantity demanded of a good to a change in its price when all other influences on buying plans remain the same. So price elasticity of demand is a measure of sensitivity or responsiveness of demand to changes in price. It's calculated as so. It's the absolute value, we'll talk about in a second, of the percentage change in the quantity demanded divided by the percentage change in the price. Now, why do we take the absolute value? The reason why we take the absolute value is because it's always going to be negative. Because of the law of demand, if price goes up, quantity demand is going to go down. Price goes down, quantity demand goes up. So we know that if percentage change in price is positive, the percentage change in quantity is going to be negative. Okay. Now, by the way, the other thing to note here is this percentage change part. That percentage change that takes out the units. And so the example of quantity demanded going from 99 to 100 when price went from, I guess, it should have been going from 2 to 1, not 1 to 2. But anyway, so it shows that it's not a 1 unit, but it's a percentage there. So to calculate it, the one thing we're going to look at it as an average price. All right, we're going to look at two prices. We're going to look at the change in the quantity demanded as a percentage of the average quantity demanded change. All right, so let's look at that. So again, price elasticity demand, percentage change in the quantity demanded, divided by the percentage change in price. So we call this the midpoint method, and I'll show that in a second. So it should actually be down here, so it's not confused. All right, so percentage change in quantity demanded over percentage change in price. All right, my little handy drawer here. And there. All right, so this top part here, that's going to be your percentage change in quantity demanded. All right, so it's as you move from 2 points. All right, so let's say those 2 points are Q0, P0 and Q0, P1. All right, and we'll show that in a second. So it's the change in quantity over the average of those quantities. All right. So let's say you go from 2 to 1. All right, so quantity goes from 2 to 1. All right. So 2 minus 1 is 1 over the average of 1 and 2. And so 2 plus 1 is 3 times 1/2 is 1.5. So this is your percentage change in quantity. Down here is going to be your percentage change in price. It's the change in price over the average of those prices. Now, this may look a little bit confusing. You see a lot of fractions in there. Well, here's one thing that we can do right off the bat. All right. This 1/2 here, all right, you see it in the denominator within the numerator and denominator within the denominator, but either way. So if we have our entire equation here, let's say that we multiply both the numerator and the denominator by 1/2. And so it's really just 1/2 over 1. And so when you do that, this would cancel, and these would cancel. Now, this is okay because with a fraction, as long as you do the same thing to the numerator as you do the denominator, you're not changing that fraction. And so all of this just breaks down to right here. All right. So to calculate the price elasticity demand, absolute value, Q0 minus Q1 over Q0 plus Q1, all over P0 minus P1 over P0 plus P1. So if we keep going here, all right, let's look at an example. All right, so let's look at let's say we have an original point. All right. That's our P0 and our Q0. Now say we have a new point, 1950 and 11. So we have our P1 and Q1. So Q0 minus P0. All right. Actually, let me do it this way. Let me insert text box. Right. So we have, again, Q0 minus Q1 divided by Q0 plus Q1. So we have these here and here. All right. Oops. All right. And so Q0 minus Q1, so we have 9 minus 11. divided by 9 plus 11. Oops. 9 plus 11. Now, again, this is a little bit off because they didn't get rid of the halves in there, but it's okay. And then we have divided by the percentage change in price. Oops. So we have P0 minus P1 over P0 plus P1. So we have 2050 minus 1950. And so we have P0 minus P1 is just going to be 1 divided by 2050 plus 1950. So it's going to be divided by 40. So, I forgot to up here. And so we have, this is going to be minus 2 divided by 20 over 1 divided by 40. All right. And so we have minus 2 over 20 is just minus 1 over 10, minus 1 divided by 10, all divided by 1 over 40. And if you go through, whatever you do the denominator and you do the numerator, so if you multiply the top and bottom by 40, you get 40 divided by 1 here, which just becomes 1, times 40 over 1 here, so you get minus 40 over 10 equals minus 4. Take the absolute value, you get 4. Right. So now, the reason why they have the 20 here is because when you do the midpoint formula, you're finding the elasticity as you move from one point to another. So it's basically the point right in the middle here. So what does that mean? Why is it good? What does it say? So it says as you move from the price of 20.5 to 19.5, your price elasticity of demand is 4. So it means that over this range, as price goes up by 1%, quantity demanded goes down by 4%, and vice versa. If price goes down by 1%, quantity demanded goes up by 4%. Okay. So this just kind of breaks it down step by step. The price of pizza falls from 1950. Quantity goes to 11. All right. Keep going through. All right. So this is kind of what we had here. So the percentage change in quantity is change in quantity over quantity average times 100. So we have quantity goes up by 2 divided by 10. Price goes down by 1 divided by 20. So you get, over this period, quantity went up by 20%. Price went down by 5%. 20 divided by 5. And that's where you get your 4. Okay. So again, the price elasticity demand, percentage change in quantity demanded, divided by percentage change in price. In this range, price changed by 20%, or sorry, quantity changed by 20%, price changed by 5%. Okay. So let's look at another example here. Let's say that the price fell from $5 to $4, and when that happened, quantity demanded increased from 90 to 100. So price went from 5 to 4, obviously not scale here, and quantity demanded went from, quantity demanded went from 90 to 100. And so if we take this here, price elasticity demand, absolute value, percentage change in quantity demanded divided by percentage change in price, Q0 minus Q1 over Q0 plus Q1, P0 minus P1 over P0 plus P1. And so we have 90 minus 100 over 90 plus 100, 5 minus 4 over 5 plus 4. And so we have 90 minus 100 is minus 10 over 90 plus 100 is 190 over 1/9. Now, when you have fractions within fractions, you want to get rid of them. And so the easiest way is to get rid of what's in the denominator. And so if you multiply both the top and the bottom here by 9 over 1, and so 1/9 times 9 over 1, that's just 1. And so 9 over 1 times minus 10 over 190, all right, is going to come out to minus 9 over 19, or 0.473.